The project is going to be called You Up, and the gist is my wife and I really, really suck at sleeping. We're just awful at it. And so it might be 3 a.m. and we'll just be chilling, and we might not know that the other one's awake and we could be chatting. We'll just be laying there trying not to stir the other one. And so the idea is if one of us presses the button, nothing happens. But if both of us press a button within an allotted time, a little light turns on right here-ish, and we know we can chat. So very simple. So there, lurking down behind my bed on top of an air filter is You Up. Behold it in its majesty. So you'll notice the light has gone out. Thank goodness. Yay, timing. So if I press one button, which is taped to the bed, as one does, you'll see it's still off. But when I press the other button, also taped to the bed, the light is now on. So that's all there is to it. If both people press the button, the light turns on, and we know that it's okay to chat without waking the other person up. Because we're both really, really, really horrible at sleeping. So this is actually going to be pretty darn handy.
Alright, first let's do the electronics. Eligo is an Arduino knockoff, same exact idea. This is the diagram and this is what it looks like in person. Since the in-person one is always hard to see, we'll visualize things with the diagram. Also, you may have noticed this diagram is shamelessly taken from an example project, but I actually think it's pretty cool that something so simple that it's used as a sample can actually be turned into something useful with just an idea and some code. Anyway, on to the electronics. The Arduino, or in this case Eligo, is like a really, really dumbed down computer. The wiring is all going to a thing called a breadboard, which has nothing to do with bread, but is a nice simple way to set up electronics without soldering, even though, spoilers, this project does involve some soldering later. The very basic gist is that the flow of electricity tells the Arduino what it needs to know, and is also how the Arduino controls what happens. In our project, the Arduino is waiting for input from two buttons. When a button is pressed, it causes electricity to flow back through this black wire and let us know that the button for that specific pin was pressed. And same goes for the other button. If both buttons are pressed, our code will tell the Arduino to send electricity through this red wire, through this resistor, and through this red LED which lights it up. Then it goes back to the ground because, grounding electricity is a thing. To help make a little more sense of how buttons and breadboard circuits work, let's tweak our setup such that the resistor is in the same row as the button. In this case, the electricity would flow through the button, through the resistor, and make the light turn on when the button isn't pressed. When the button is pressed, the light will actually turn off because the electricity is going back down to this row instead. Here's a quick and simple example. This wire is connected to the 5 volts and electricity flows through it. It then follows this plus column up to the resistor. The other side of the resistor is in the same row as our button, so the electricity flows through our button to the resistor in this row. Side note, you can add multiple resistors or different resistor strengths to control the brightness of the light. Anyway, the electricity flows through to this green light and then to our ground through this yellow wire. But if we press the button, the electricity instead flows back to this row, through a red light, and to the ground via this black cable. Alright, enough circuit information, back to our initial setup, and let's dive into the code. Alright, so now we're here for the coding. We're going to make this thing actually do something. So here we have a new sketch, and if you're following along with the Eligo tutorials, it's going to look real similar to this digital inputs thing. And actually I'm going to grab some of their code so I don't have to type it out, but I will explain what's going on. So let's paste that in here and I'll talk about it. So first, this setup section. This happens when your program starts, and as the name suggests, it sets up whatever you need for your Arduino project. So here this is the standard thing for an LED pin. It wants to output light. So what this means is it wants to pull up to high instead of low. So there's high and low voltage. And so if it's sitting at high, the button is not pressed. But when you press it, it goes to low. And so that's how you know the button is pressed. So a little bit more about Arduino there, but we want to set this up like that. These are variables. So as you can tell from the variable names, the LED pins for the pin that goes to the LED and the button A pin and button B pin are setting which pins are getting used for these buttons. And so that will line up with what we did with the actual hardware. This is just a nice way to do things. So if I want to change which pin the LED is on to 4, then I don't have to change it in, say I have this referenced in 5 places. I only have to change it here, and also when I'm coding, it's not just some random 5, it's a well-labeled thing. So there you go, that's what that's for. This seems pointless, so I'm gonna delete it. So, alright, in terms of things we need, we're going to want to, let's go to the loop first, and then we'll work through what we need. So the loop is going to run, well, I guess I can leave this up while I'm explaining it, but this is just going to loop forever. So anything you're going to want to have happen in your code, you're going to want it to happen here for the most part, because this is just going to run continuously and is going to be able to drive your logic. And of course you can call other methods, whoops, what am I doing? Brain malfunction. Other method like so, but that's still being driven by this loop. So anyway, let's think through some logic. Well, first, so we want to make sure the light starts as off. So LED pin low. Setting it to low is how to turn off the LED light. So there you go. So we just want to make sure it's set to low initially. I think it would be by default, but it's not going to hurt anything to ensure that it is. So that's what I'm doing. Alright, so here's how I want this to work. I want it to be such that if one person presses the button, nothing happens, because the other person might still be sleeping, but if the other person presses the button, then the light turns on. But if it's been like 15 minutes, then if the other person presses the button, the first person may have fallen back asleep. So I want to make it such that if after 15 minutes nothing's happened, we reset the timer, and if the other person presses the button, now we're waiting for the initial person, so that both people are conscious, and if both press the button within the time window, we can get up and chat, and yes, chat, you perverts. So alright, so if the button is pressed, digital read button, let's do A. So like we were talking about here with the pull-up, where if it's high, it's not pressed, and if it's low, it's pressed. We're seeing if it's low, meaning it's pressed. So I'll just make a note. Low equals button has been pressed. So if the button is pressed, let's keep track of the time. So brief note, time can be measured in long via millis. If you fetch millis, it gives you a big number which keeps track of milliseconds. And so if you're real new to coding, it's going to be a quick little variable tutorial real quick. But short number is going to be a short whole number like this. But long is a long whole number like this. And if you use this number as an int, it's gonna, I don't remember the exact number it'll give you or anything, but it won't be this. It'll be some other number. I don't remember if it's like the negative or what, but or I don't remember what exactly it gives you, but it will not be this number, it'll be some incorrect number. So if you're going to use a really long number, it needs to be a long. So we are going to declare some long values to keep track of time. And so button pressed time A is long. And it'll default to 0, but doing this keeps it pretty. And I'll just copy paste because we're going to want the same thing for button B. Alright, so continuing with our code, if the button A is pressed, we want to keep track of when it was pressed. So button pressed time A equals millis. Boom. So, and this made me remember another thing to share. So in setup, so if I go to tools and serial monitor, and looks like I need to, so it actually registers as an Arduino Uno, even though it's the Arduino, but the correct board is in fact the Arduino Uno. For the Arduino Uno, it's legit just a knockoff. So for anyone using exactly what I'm using, but I just opened the serial monitor, and right now it's blank, but this is how you're gonna do a good amount of your debugging. You can log different things as you go, and it'll display here, and it's super duper helpful. But for this device, we need a baud rate of 9600, and so you just declare that by saying serial.begin and 9600, and this makes it so that you're going to get an output. And so the reason I just remembered that now is it makes sense to say, hey, this button was pressed. Button A was pressed. And again, if you're super new to coding, print line means it prints and then enters to the next line. So if you see this a bunch, it'll say button A was pressed, enter, button A was pressed, enter. But if it was just print, it would look more like this in the serial monitor. I keep wanting to say the log, but that is not what it's called. It's the serial monitor. Anyway, so the other thing with this is if button pressed time of B is greater than 0, let's say, because I'm going to reset the time. So if the timer is still running, then we'll know, okay, we're good to turn on the light. So digital right LED pin high. This turns it on if I can type. Turns on the LED light. So we want to keep track of, is the light on? So this is going to be another variable we'll need. And so in Arduino it's a bool. Some languages call it boolean, but on all bools are true and false. And so actually is light on will be starting with false. So yeah, so we're just going to keep track of this so that we are able to do some extra logic with that. And so, alright, so I'm just going to do button pressed B, just basically the exact opposite of what I just did. Boom. And since I want to reset the time, because it should only keep track up to 15 minutes, right? So actually first, let's do another long. So let's keep all the longs together. But we're going to want probably two different things. So we're going to want a variable for how long until the buttons reset. So one's been pressed, and after 15 minutes, we'll reset it. And then also we're going to want another variable for how long to keep the light on once both buttons have been pressed, because you don't want to just leave that on indefinitely, because then you'll have to reset the whole app, and that's silly. So first, let's say time out length button. Okay, and so here is one of the big initial learnings I had with Arduino, because I like to do variables like this, like so. So this would be milliseconds to seconds, seconds to minutes, and then however many minutes I want. So that's just an easy way to make it easy to just go, okay, I see what you're doing here. I mean, this isn't a difficult equation. You could just write the actual number, but this makes it so you can go, boom, 7 minutes instead, or whatever, and yeah, anyway, it's just the thing I like. But if you do this, then this will not register correctly because it thinks it's processing a bunch of ints. It does that, and then it saves that value as the long. So I think you only need to add one value as an L here, but either way, this doesn't really hurt anything, and it makes it get the right number. So yeah, so add the L's to make your long work, or you could just add the actual number without the equation. So just the thing I like, but I like readable code. So timeout length light. It's hard to type and think and talk. And I think let's do 2 minutes. It's probably a good amount of time. It doesn't need to be on that long. So, okay. So we've got probably all the variables we'll need, but let's go ahead and reset the time if the button has been pressed and 15 minutes have passed. So if the light is not on and the button pressed time is not 0, and you could just say greater than 0, but if any weird thing happens, somehow it goes negative, it never should, but if we screw it up, this will fix it. So maybe I should do it the other way so we don't have any band-aids, but you know what, I'm already typing the next part, so boom. But no, I mean, kind of 6 of 1, so whatever. So what I'm about to do is time out length button less than millis. Okay, and so what this does, so button press time A, we had it capture millis, which is the milliseconds at that moment. And so if we add the timeout length button, which is our 15 minutes, then so it's always capturing the millis of the moment, right? So whenever this plus 15 minutes worth of milliseconds passes, it'll be the current millis will be greater than that value, right? So that's what's happening there. And so in that moment, we'll say button pressed time A equals 0. And that's all we have to do because it's just resetting a time. The light's not on, nothing crazy's happening, just reset. And so we'll do that again with B. That should be it for that. Alright. So the last part should just be if the light is on, so is light on. So what we're doing here is turn light off after a set amount of time. So I don't want to say after 2 minutes because what if I change this value? Then I'm lying in my comments. You know? You don't want to lie in your comments. So we'll say millis minus button pressed time A is greater than time out length So I guess it's very similar to this. It's just, I don't know, my brain's weird, I guess. But it's, yeah, basically the same equation, just presented a little differently. So we're just making it so that if now minus when the button was pressed is like the difference is at least 2 minutes, then we know it's passed. But we have to do this for both buttons because whichever one was pressed more recently is the one that matters, and so this is just one way to do that. We could keep track of which button was pressed more recently or something as a different way to approach this, but this is perfectly easy, so why not do it like this? I like copying and pasting, as you may have noticed, because all I have to do is change one letter. So the light is on, and I want to turn it off. So digital right, LED pin low to turn off the light, and then is light on, no. And then, yeah, we would need to reset everything, so button pressed time is 0 for A and B. And I think that is it. I need to get my camera back plugged in so that I can run it, and then I will show ya. So I'm just clearly crushing it left and right now because not only are there errors in my code, but for the segment here where I was going to go through that, my audio didn't record. So basically I'm just being big brained to show you, hey, when you have errors in your code, it doesn't compile and it actually does show you where the errors are. So that's nice and handy. So I just need to tweak this to be button pressed time A and B, and it will compile and we will be good to go.
There aren't a lot of certain truths in this world, but one of them is you should never, ever post a soldering video to the internet. I saw a post with a perfect soldering job, and all the comments were like, it needs more heat, and stuff like that. So this is my first soldering ever. So be nice, internet, and take this with a grain of salt. I'm gonna get more practice, so calm your tits.
I'll do a 3D modeling and 3D printing video at some point, but this is not that one because it's soldering time. So I'm just going to nab this guy's model because it already exists, but I will have to tweak it a little bit. So here's me busting through that process real fast. And then once it's printed, we'll ruin it by doing some first time soldering. Heck yeah, dude. So all that's really happening here is this guy had made a 3-button push button, and I just want 1 button on each side, so I'm just breaking it down to be just 1 button, and then we'll just print it, and really all that's happening here is I had extra footage that I don't want to waste, so that was 10,000% speed, and oh hey look, we did it, and it's time to print, cool. As is often the case for those of us who have never soldered before, I don't have a soldering kit, so I'm going to order this one, and if it's still around and looks decent by the time I post this video, however many millennia from now, I'll leave an affiliate link in the description.
So as exciting as it would be to solder on wood, we are going to move it over in just a second to a different workbench, but this is your actual soldering iron. This is apparently a little stand they've sent me with, which is real snazzy. So we'll set this up so that there's an actual spot for this to rest on. These are the soldering iron tips. We'll be putting these on that, obviously. This is just like little tweezers. I think they're supposed to be anti-shock tweezers, which sounds nifty neato, but you know, good for control. And this is your actual wire. You have to use actual metal material to solder onto the electronic wire, and this is that. So we'll be unraveling a little bit of this, like so, and then soldering it on. And this is your wire cutter, which is great, and I kind of wish I had found this a little minute ago, but that's cool. This is just an electronic wire they sent, and this thing is what's called a desoldering iron. So you can remove soldering waste with that, basically. It does come with a tip already on, but if you don't like that one and want to use a different one, you just unscrew this part and pull it out and put on whatever tip you want. This one works just fine for me, so I'm going to re-screw this back on, but figured I'd share in case you didn't like the default tip. Alright, now you can see the light indicating that it's heating up. You can also smell that it's heating up, which is something. Got my button, got my solder out. Alright, this should all be good to go. So I'm going to first test a little bit of solder. That seems to be very much working, which is great. So to make it so that it's easier for me to just solder, not try to hold a bunch of stuff, I'm just going to prep the wire and slide this around the wire. That's the plan. Alright, that's perfect. Okay. Again, I'm not an expert, so there may be slight differences to what I'm doing that are just generally better, but that's definitely the gist. I'm very much appreciating this holder, so hopefully whatever you got also comes with some sort of holder, and if not, definitely suggest setting something up as a holder of the heating iron, because you can't just set it just anywhere for very obvious reasons. It is hot. Almost exactly what I wanted. Alright. Round 2.
Alright, I think you get the gist at this point. I'm soldering on these nice long wires to the buttons a total of 8 times to get these big buttons to replace the little buttons. This video is getting pretty long, so let's just go back to the final result and wrap things up.
So whenever I press one button, this light's still off. This button, and boom, light's on. It just shows you with pretty basic tech you can make something sort of useful out of it. So I'll see you in the next project.